I'm going to jump straight into it. We have Steve Clement and Christian Studer presenting MISP, Threat Sharing Platform, a platform for sharing, storing, and correlating indicators of compromises of targeted attacks. If you give them a warm welcome applause, guys.
Thank you very much. The overarching title is rather generic, so we might be a little bit flexible in the beginning. Basically, my name is Steve Clement. I'm an information security engineer for Team Circle. I have been working for Circle for over 10 years. I've been in InfoSec for more than 20 years. And currently I am working out of Tokyo, and mainly I do MISP-related stuff, from orchestration of the thing to documentation, translations, a lot of testing. So that's my core task at this moment. It will be a two-parter, so we will have a tag team relationship during the next few minutes with you, where Christian will go through the basics and what is MISP, why is MISP, and then I will take it further with a couple of examples what it actually looks like, and then depending on what you're interested in, we might either go into a more philosophical discussion about how do we actually decay data, when is data dead, including how can I put data into a value system, how valuable is data, and perhaps people who participate in sharing that data. So first up is Christian.
Good afternoon. My name is Christian. I'm working for Circle, mostly as a software developer. I am the one behind all the interactions between MISP and the sticks format. Today we're going to speak about information sharing, and more specifically about the malware information sharing platform. So Circle is mandated by the Ministry of Economy and acting as the national CERT in Luxembourg for private sector. We are also developing MISP and many different open source softwares. For MISP, we run multiple instances, multiple communities performing active information sharing every day. I want to mention that for MISP, we also are co-financed by the by the European Union. Speaking about the communities, so Circle operates many different large communities. One of the biggest one is the one for the private sector, hosting more than 1,000 organizations. This one is actually open. Every organization who wants to join us can just send us a request. There are also many other communities hosted by AusCERT, NATO, some security vendors or researchers. For the most active ones, we have usually an average of 4,000 indicators shared every week. So let's speak a bit about a history of MISP. Everything started around 2012. One of our colleagues attended a malware analysis workshop, and actually all the different attendees realized they were all working on the same malware analysis. So they wanted to figure out a way of avoid duplicating work and find an automated way of sharing the information they gathered. Christophe van der Pla, working at that moment for the Belgian CERT and working now for NATO, then worked on a platform which was some of the first versions that would become later MISP. Now, as you know, MISP is a community-driven platform led by and the development is led by Circle. So you could basically find many different usage for a MISP. As an analyst, you would be interested in sharing information with your colleagues, sharing indicators in operational security, also gathering information about specific adversary groups, or if you're more in the financial sector, share financial indicators. Here is a standard overview of our governance model. We, as the main developers of MISP, we are also some of the main users. We have the MISP features we want to present, we want our users to feel comfortable about. So we give many trainings during the year all around the world. We also have a yearly summit during our conference in Luxembourg called Hack.lu in October. And you can also use GitHub to raise any issue you have. We use Gitter, which is a chat application to keep contact with our users, and also for users who want support about MISP. So MISP is a modular piece of open source software. We have everything related to the software, so the MISP core, with basically, the code related to the platform itself. The MISP modules for people who want to enrich data shared in MISP. We also have a powerful API in Python called PyMISP if you want to automate some requests. MISP has also some templates that can be used to give more context to your data. So the taxonomies and the galaxies, I will present it later. Also the notice lists and the warning lists to avoid false positives. Steve will speak about it. What is important is we want to provide an open source standard. We do think that sharing information should use open standard. So what could MISP used for? Basically, you would use it as a detection matter. Perhaps you see some IP addresses you want to feed your detection systems with, or you see some malicious IPs you want to feed your firewalls with to block them. But also, you may want to know who is targeting you, who are your adversaries, and you can also use MISP to perform intelligence.
And in that sense, what is quite beautiful by design is that all these data flows can be exported and ingested into third-party applications. For example, for the entire intelligence analysis, if you have a Maltego license, you could just install a small plugin and it will actually just enrich now Maltego with all the data that might be in your threat sharing platform. The other thing I wanted to mention earlier is For the use case of law enforcement or other more legally strict entities where the data actually might need to be notarized or might need to go in front of a judge, we are living in a world where this becomes more and more important, that things are legally safe and sound. Judges have understood that cryptography actually might even give you a good legal basis on the authenticity of certain pieces of data. And as it stands now, the data points that might be in our platform, they are not notarized. So if someone goes into the database and kind of tweaks something, that is a problem. And this is one of the challenges we also face for the future. What are we going to do? How can we make sure that this is actually legal data? And there, dare I to say, technology like blockchain might be a very interesting use case where you would put all that stuff into the blockchain and, well, now it, in theory, cannot be changed, or at least it gives you a certain amount of insurance.
So one of the features about MISP is you can totally have your own MISP instance, totally offline, where you share data with USB sticks, whatever. Or you can have it online, synchronizing data from the other instances, and so on. Another feature, very important, is the ability to share data through different formats. Sticks, for example. You also may want to feed your antivirus systems with some Yara rules, and so on. Important characteristic here is we want it to be modular. We want it to be customizable, so it fits your workflows.
Yeah, and just to reiterate the island mode, or rather an air-gapped use case, by now you might have seen that this is really flexible and maybe overwhelming, but I'm fairly sure that depending on which sector you actually work in, you might already now have identified a certain use case how you could use it. The air-gapped one might be I have to make a digital forensics acquisition of a very high-profile case, and this is classified data. This can only be done on a system that is not connected to any external networks. And because, again, of the modularity, if you only have a MISP core installation, it does not rely on any uplinks to the internet, but you can just quite easily, in offline mode, just populate your instance and then be more or less sure that the data just really stays where you think it physically is.
So we have a pretty basic way of sharing information. It's a data structure called an event. An events are basically the data that are shared among the different instances. Here is what an event looks like. So basically, it's some metadata that can be understandable by a human. So with a name describing what we're dealing with. You can also add some context to it with some tags. It has a certain distribution because you want to distribute it to your community, to all the communities, whatever. We still will speak about it.
Mm-hmm. We get regular questions about the best practices when it comes to threat intelligence, and the only thing we really can say, it highly depends on your use case. If you have humans in front of a computer that need to make sense out of a couple of hundred events, then, for example, if they are the operators who input the data, the information, what the event is about, needs to be human readable, and your community needs to understand what you mean. If it is a computer to machine-to-machine thing, obviously then that field doesn't really become that important anymore. But I would actually argue for always having a human-readable information field that you can analyze afterwards, because it's I think it's a fallacy to think that the machines will eventually take over and we're just going to put it into a black box that puts some algorithm on stuff and then we all are going to be happy. That is a bad approach to things. The other thing you see here is from the get-go you see what is related to this particular event, and that becomes the most interesting if you have very unique indicators like that. As a human, you say, this IP address looks really weird, it smells, but I'm not really sure. And then if you see that in your data set of a couple million data points, it is not being flagged, but you are sure it is malicious, that gives a certain value to such an attribute. But of course, if you see, well, this is on in 1,000 other events, you know, okay, well, it's maybe something more generic than that.
Well, having events is cool, but how is the actual data stored? Well, we have this pretty standard data model of attributes describing IP addresses, hashes, and many different types with their value. Also, as for the event, you can attach some tags to give some more context. The problem with that, it's a pretty simple way of describing things, but also in this example, we might get in troubles if we had to represent more hashes, more files, and we would not know which hashes belongs to each file. So for this kind of situation, we also have objects that are basically simply containers around attributes describing the context between each of them. Basically same features than the attributes. They can have tags, they have a distribution, and also an IDS flag. Do you want to say about the IDS flag?
I will talk about that in a minute.
Fine. Yeah. Then with an event, you can kind of tell a story with some objects and their references. References are basically the relations between all the objects you can have in an event. References can also be between objects and between an object and an attribute. We'll just see it. Here's a more visual representation of these objects that are provided again with the event. Basically, it's more comfortable with this graph to see that we have a file object, an IP object, and all the different relations between them. Also some relations with external attributes, single attributes.
Now the main question here obviously is, how do these relations come to be? Are they a manual thing? Are they an automatic thing? And the underlying philosophy of our platform is you can have both worlds, but ideally you sort of automate it, also to stimulate the community at large to think about complex problems in a more algorithmic way. Again, not the biggest fan of artificial intelligence and machine learning, yet I really think that there is a potential to use those concepts and all these quasi philosophies to make threat intel sharing a way better tool than what it is. I don't want to say our tool is bare bone, but it's just so complex that you can really do everything with it. You really just have to do it.
Well, having data is fine, But what is really important is the context behind what makes the data actionable. So what can the data be used for? Who can we give the information to? What concerns is the information trying to address? And so on. For those concerns, we have multiple flexible ways of adding context, such as the tags, the galaxies. So basically, the tags are a simple way of data classification for an event or an attribute. MISP includes around 80 existing taxonomies. You can also create your own ones. Imagine with this example of TLP, you can also filter data using those tags. Perhaps you want to synchronize data that is only TLP white, or you want to restrict exporting data that is TLP red. For that purpose, classification must be used globally to be efficient.
And I really motivate you to check out all the taxonomies that are out there, because you will also see that it doesn't only include technical taxonomies, but it might actually have a drugs taxonomy where you have a certain type of chemical substance classification. So it's really a taxonomy at large. And that shows you the broader picture of what this information sharing platform is really about. It's about information. The M, again, Christian explained, it's sort of a historical thing, but it's not only about technical attributes, but it can be about any information, any data point you can sort of enrich with in this case, with tags.
Another way of giving context is what we call galaxies, that are basically describing if the event is has some ad hoc patterns attached. Those indicators are actually describing a certain tool. We're also supporting the matter attack matrix, which is basically a kind of list of attack pattern that you can visually and graphically attach to an event or an attribute. Anything?
No, I'm good.
Fine. So I'm going to show you after Steve's demo the REST client we implemented in MISP.
Next slide. All right. I will give you a quick rundown on what all of that theory looks like in practice. First off, if you want to test it, like really follow later what I show you now, we have auto-magically generated virtual machines in VMware and VBox format that get generated each time there is a commit in GitHub. Side note, that is really neat if you need to do testing, or if you have a large user base that sometimes says, hey, this broke between commit A and commit B. Now I have a more or less easy way of just downloading a self-contained and, in theory, working image of our fairly complex software with yesterday someone explained it as a dependency hell, which I must admit, yes, it partially is. Nevertheless, it is powerful as such. So if you boot up the virtual machine for the first time, you're asked to log in. The standard password is admin@admin.test. The password is admin, and you will be asked to change that password. Fun fact, I wrote buggy code. The generator used as a username and password combo for SSH, MISP password 1234. At the last conference, someone tried to install it on a live server on the internet. It took 30 minutes to be owned with MISP password 1234. not too proud about the oversight, but it's historical. Nevertheless, this shows you how fast it is. And yeah, there's our combo in some database where they do automated attacks, obviously. Also meaning, because the password is still MISP1234, in the VM, don't deploy the VM on a public IP address. Sounds obvious, but sometimes you just deploy by mistake. Once you logged in, you see the first screen that tells you who you are, which your user is, and straight away you also see, oh, there's an authentication key. This key generally is used for automation, for your MISP API calls. Be careful, it matters which user you use. Create a synchronization user or an API user that is strictly limited to whatever data it should get at. Because now I am the site administrator, meaning if I have 500 organizations on my instance, I can see all these organizations and their data, which is for obvious reasons, because you do need in a community one site administrator that can actually just manage everything. Whereas an organizational admin would only see his organization, the site admin sees all the organizations. The home screen is very sad and empty in the beginning. This is your main view, especially as an analyst, where you would see all the events that are being added either manually or automatically. I will now show you how you can quickly just populate an empty MISP instance with a feed. We have a plethora of feeds already included. They are all open source intelligence feeds. Ideally, if you ingest a feed, you would ingest it with the MISP format because it is lossless and you will have all the information. But of course, you can also use other sources, like if you have only a CSV feed or something, you can also ingest that from third-party vendors. So I just need to select and enable my feed. And once I have enabled it, I just download it. So if I now say this enabled feed, fetch all events, what this does, it will now populate my, my information sharing platform with whatever data is already included in that feed. A cool thing we have is the feed overlap matrix, meaning imagine you have 5 data feeds, 1 or 2 are commercial, you pay a couple of $1,000 a month for it, and they promise you a very unique feed with very unique indicators. How can you check that? You cannot really, but what you can do is use the overlap matrix, because then you will see, okay, here are all the feeds that are, for example, activated on MISP priv. Oh, there's some that are 50% overlapping with each other, or maybe 20% overlapping with each other. It's an easy test to see whether you get value for your data when you have such feeds. Let's see if it has actually populated anything. And yes, you see now, slowly but surely, data is coming in. This synchronization process is very timely if you have a slow internet connection. So this will now take quite a while. And you see the second event here already has way over 1,700 attributes. So I would suggest we quickly create a small event ourselves. For example, we might have seen an APT32 thing on the paste side. You would then generally add a good descriptive name to it. And then the most important thing, because again, think sharing, how do I share it? Do I share it only with organizations that are logging into this MISP instance, or would I also share it with organizations that have other MISP instances automatically synchronizing with myself? And what if these organizations have other organizations behind them who synchronize? So the distribution level would be the first and foremost place to sort of select how far does this event want to travel through the network. In our case, if I say your organization only, if my organization would be AusCERT, I would only share it with the AusCERT organization on my MISP installation. If I say this community only, that means, well, whoever is connected onto this platform, they will get that event if I share it with them. And then connected communities is basically one hop further. If there is a company that syncs with me directly one-to-one, I will sync it there as well, but it will stop there. And then basically all communities means it will go through the entire network. If there's 50 MISP machines connected, it will basically travel towards all those connected machines. Okie dokie, this is my first event. Best practice, okay, let's add a tag. I would say that maybe I want to TLP classify this. This might be an event that is TLP white-worthy because I found it in a paste site, so maybe I want to share that to everyone. So I add this tag. And now, again, bear in mind, if I would be synchronizing, I could say on my sync link, I could say, okay, if you try to synchronize something tagged with TLP right, don't worry about it, just push it through. If it's TLP red, discard it. Now, how do I populate it? There's a fairly simple but effective free text import tool where if I now have my my paste with all these indicator of compromise in, I would just simply copy paste it and submit it to MISP. What it does now is it will offer me some presets by what it thinks it is. For example, here, moo.jpg URL thing, oh, that's a network activity of type URL. Or bigmac.jpg, that might be actually a file. And now I can basically fine-tune how I want this to be attached to my event. The IDS flag means that if this is set, it will be exported to, for example, my my suricata rule set, or the rule set that I use to fine-tune my firewalls. So you want to be careful here. And as a colleague pointed out, for example, we have a very generic thing down here, bigmac.jpg, and that is already marked by default. That might not be good. That might be a false positive. And here you see this is a rather manual job where you need people who kind of understand more or less what they are doing. Once this is done, you submit all the attributes. What it does now, it sort of ingests them, but it will go into a background job where it does all the enrichment. So, for example, there is a URL, and you want to get the whois data of that URL. It's gonna of that domain name. It's basically now doing all these lookups. Oh, it is actually a domain. Does it have an IP address? It's a Bitcoin address. Does it actually have any activity on the Bitcoin address? And so on and so forth. So that is happening now in the background. And as we reload, we should see that now we have an event with a main event, apt32 blah, and then with the relevant attributes attached to that event. And now, and you will see, this is why it is complex. I say, okay, well, this particular URL is actually TLP green. So now I can tag only that URL as TLP green. And again, all my filtering rules around that would act accordingly. Okay, how many minutes do I have? 5 more. Okay, great. So we'll show the REST client next, because obviously now we have a lot of data in our instance. But what can I now do with that data? And this is also our shtick, where we want to motivate you to try and just automate it as much as you can. Use Python, use it in scripts, and so on and so forth. Christian's going to show you how that is done in a few easy steps. C'est bon.
So here we have our homepage. We go to Resk client. So with the Resk client, you can basically do many different things, such as add attributes, add events, edit them. What we want to show here today is the Resk Search, where you can filter some data with some, and export it, for instance, as one of the formats here. So What is important is we have some mandatory field. Obviously, the return format is important. We'll choose JSON because it's the one we like with MISP. Type, okay, I want some IP sources. And I will also not want to show all the IP sources, but the last ones from the last 2 days. What show the result? Okay. Then we have the results. Okay. What is interesting here is we have programmatical way of doing it automatically with curl or either with the Python API, PyMISP, and all the commands are shown as well. If you have troubles building your own queries, we also have a query builder helping you doing it. So just have the same one here. And again, the last 2 days. And here we can inject it and have the exact same result.
Like that kind of stuff you can also bookmark. Because again, well, maybe you have an operator that wants to use this, but is not necessarily very versed in writing and thinking, dreaming JSON. Then the bookmark queries are fairly handy. But you see, like with the Python snippet we have there, it's very easy to kind of get started. You use the query builder to make something more or less interesting of the data you want to get out, and then you can use the script snippet that gets produced. Further on, of course, the PyMISP API has a plethora of examples. It is close to obscene how much Raphaël Vinot, who is the main API developer, has included. And there's also a Jupyter notebook that is really fun because it's way more visual and it also is all tested. So that's also one way if you want to get into automating all that stuff. I have a couple more minutes left, I guess. Okay, so I can show you something more. What you prefer to do? Do you want to go a little bit off track and do something a little bit more experimental, or shall we go with the usual shtick? I don't know. Not too much. 2 minutes, okay. Okay, well then let's go off the deep end. Sound? No sound? No sound. That is very disappointing because it doesn't work without sound. Oh, well, maybe it does. Well, basically, this is a Flim Bus, and they now show how the Flim Bus is actually made and what the different steps are to create such a very high-precision device. The overall idea was, how valuable is what we see there? What do we take from this? It's informational, maybe. How good this information is doubtful at best. So yeah. Basically, the granddad wondered, he was always interested to know how these plumbuses are being made. And this is sort of the self-criticizing part of the talk, where if you have 4,000 organizations sharing data with each other, it might just be a big pile of trash. I'm not saying the data is trash, but I'm saying that is an issue, and that is an issue we need to sort of solve. And if there are big vendors out there who say they have solved it for you with some Flim Bus device where you don't really know how it works, well, I don't know, think again. We are now working on a decaying model where we say, okay, You have certain indicators like IP addresses, phishing URLs. How does that decay? It's easy with milk. It's more difficult with a phishing address, because even if it's gone, is it really gone or has it moved? Same with IP addresses. So basically, we're trying to implement some fancy mathematics to sort of say, okay, these are the source organizations who have shared that. They have a certain trust relationship. They are trusted because they are, for example, AusCERT. They know what they're doing. So that has a different trust level versus this new company who might share stuff and we don't really know how valuable that is. So the combination of decaying indicators of compromise and putting a certain value on it will be extremely important for any information sharing platform to actually be useful, especially for analysis. Because you see what happens at the moment, attribution is a big fat mess that is being made worse by vendors who want to slap a name on something and off you go. And the same thing for exploits, for example. How valuable is an exploit? An exploit becomes less valuable over time, and so on and so forth. And I think our time is up. With that, I want to thank Christian very much for having given us a helping hand in making this year's presentation at AusCERT happen, because Michael, who had a couple of other workshops as well, was busy. So I thank you very much for this. Thanks. I appreciate that.
Do we have a quick question? We're very short of time, but does anyone have any questions? Very interested in decay. How soon do we expect something that we can use?
So there is a test branch, a test decaying branch, where you basically have an additional field where you can add a decay score. That is very simple at this point of time, where you can just give it a numerical value in days. But the other more experimental branch has actually also the weighting score included in that. So it decays not linearly, but in a little bit more of a fancy way. We wrote 2 papers about that. They are okay. They are not brilliant, but they are good enough to have a good idea. And we now try to implement our own papers into MISP, which is more challenging than we thought. Because on paper, it's actually pretty clear. But in implementation, not so much. Anything else?
Well, if we can give Steve and Christian a big applause. Thank you very much, guys.